Welcome to day 3 of Jamb Mathematics in 30 days. If you have not been part of this series yet, you can watch the previous videos from day 1 and day 2 to catch up with what we are doing. For day 3, we are going to be looking at indices, logarithm, and surds. And what Jamb expects you to know before you take that exam concerning indices, logarithm, and surd is 1. You should be able to apply the laws of indices in calculations. Now, there are going to be several questions that involves numbers in their index forms, and your knowledge of applying the laws of indices will help you to solve those questions to perfection. Secondly, you are to establish the relationship between indices and logarithms in solving problems. Now, you recall that in some of our videos where we talked about logarithms, we tell you that when you have, for example, log to base n of x, and we say this equals y, what this simply means is that n to the power of y equals x. This is the relationship between indices and logarithms. So you should be able to work with this when you are solving problems. Then thirdly, you should be able to simplify and rationalize surds. By now, you should know that when solving problems in surd, you should not be having an answer in n over surd of x. You are supposed to rationalize this, which will then give you n surd x over x. So we're going to practice more questions on rationalization of surds. And then finally, you should be able to perform basic operations on surds. We're going to be solving multiple questions from the previous years in Jamb to establish knowledge on these objectives. Let's go. This question from Jamb 1999 is a typical example for solving problems on indices. And if you are yet to fine-tune your work on indices, you can check out our videos on indices to brush up on it. But let's solve this and see how it's done. Here we have a squared multiplied by b raised to the power minus 3 multiplied by c, all in brackets with the power of 3 over 4, divided by a raised to the power minus 1 times b raised to the power 4 times c raised to the power 5, and all of this equals a raised to the power p, b raised to the power q, and c raised to the power r. So using this relationship now, we have to find the value of p plus 2q. So let's take it a step at a time. Here we can then give the power to each of these base numbers. So we'll be having a squared, now raised to the power of 3 over 4. Now we multiply that by b raised to the power minus 3. Then this will have 3 over 4 multiplied by c raised to the power of 3 over 4. All of this over a raised to the power minus 1 times b raised to the power 4 times c raised to the power of 5. And all of this equates to a power of p times b power of q and then c power of r. Now when we work with this, we would have a. Now 2 times 3 is 6. 6 over 4 is the same thing as having 3 over 2. So multiplied by b. Minus 3 times 3 will give us minus 9. So minus 9 over 4 times c raised to the power 3 over 4 all over, this remains a power of minus 1 times b power of 4 times c power of 5, all becoming a power of p, b power of q, and c power of r. Now applying the laws of indices, we can then write this as a, and then it will be 3 over 2 minus 1. Because we are using division here, it will be subtracting the powers. So that will be minus 1, which becomes plus 1. And then for b, we would have b minus 9 over 4, then minus the power for the denominator here, which is 4. And then c, 3 over 4 minus 5. All of this is a power of P, B power of Q, C power of R. Now let's tidy this up. 3 over 2 plus 1 would give us 5 over 2. Then here we have B. Now 9 minus 9 over 4 minus 4. Let's do that here. LCM is 4, and then this will be minus 9 minus 4 times 4 is 16. So when we do this, we are going to have minus 25 over 4. So B power of minus 25 over 4. And then C. Now for C, we have 3 over 4 minus 5. LCM is 4, so we'll have 3 minus 20 here. This will give us minus 17 over 4. And all of this is A power of P multiplied by B power of Q multiplied by C power of R. Now we can equate the powers, right? So since A with the power of 5 over 2 can be the same thing as A power of P, what this implies is that P equals 5 over 2. Now the next thing we need is Q. We really do not need the R. So for R, we're going to have B power of minus 25 over 4 equating to B power of Q. What this implies is that Q equals minus 25 over 4. Now you can do the same thing to get R, but what we are trying to solve does not involve R. So that is why you see I'm skipping R. Now let's evaluate this. P plus 2Q. Now P is 5 over 2 plus twice of Q, which is minus 25 over 4. This will mean we'll have 5 over 2, plus times minus is minus, and 2 here 1, 2 here 2, so we have minus 25 over 2. Now LCM is 2, so we'll have 5 minus 25, which will give us 5 minus 25 is 20, minus 20 over 2. And when we divide minus 20 by 2, our answer is minus 10. So the correct option here is D. Let's solve this indices problem from Jamb 2008. Simplify 16 with the power of 1 over 2 minus 1 over 2 times 4 power of minus 1 over 2 times 27 power of 1 over 3. Now, to simplify this, we have to bring them to the smallest base possible first. So for 16, you would have 2 with the power of 4 to make 16. So all of this raised to the power of minus half. Then we'll multiply this by 2 squared. Now 2 squared makes 4, so it still carries power of minus half. Then we'll multiply this by 27, which is 3 cubed. Power of 1 over 3. Now when we consider this, we're going to see that this cancels out. 2 here 1, 2 here 2. So what we have here is basically 2 with the power of minus 2 times here 2 here 1, 2 here 1. So we have 2 power of minus 1. And then we multiply this by 3 cancels 3. So this is basically 3. Now, looking at this that have the same base, we apply the laws of indices, which implies that we are going to add the powers. So here we're going to be having 2, then minus 2 plus minus 1, which is minus 1, then times 3. Now this would give you 2 with the power of minus 3 times 3. Now, we can write this from negative index to positive index. So it will be 1 over 2 cubed multiplied by 3. Now, what this would give us is 3 over, now 2 cubed is 8. So what we have is 3 over 8. That is the correct option is A. Let's evaluate 81 over 16 all in bracket with the power of negative 1 over 4 multiplied by 2 with the power of negative 1. Now, we can convert this negative index to positive index by just flipping our fraction. So we would have 16 over 81, now power of 1 over 4 now. Then multiplied by, to make this positive index, it becomes 1 over 2. Now, let's work with this. We'll bring this to the lowest possible base, and that will be 2 with the power of 4 over, now 81 would be 3 with the power of 4, or raised to the power of 1 over 4, then multiplied by 1 over 2. Now, this can be written, applying the laws of indices, to be 2 over 3, all raised to the power of 4, then times 1 over 4. Then we'll multiply this by 1 over 2. So here, 4 here 1, 4 here 1. So what we have here is 2 over 3 times 1 over 2. Now, 2 here 1, 2 here 1. So 1 times 1 is 1. 3 times 1, 3. So the correct option is A. This question from Jamb 1983 asks that you factorize completely 81a power of 4 minus 16b power of 4. Now, in order to factorize this, we have to write it such that we can get difference of two squares. So, in order to completely factorize this, what we have to do is write it such that we can have difference of two square. To get 81, we need 9 square. So I can write it as 9. Then a power of 4 can be written as a squared. Then all of this squared. Of course, 9 squared is 81. A squared squared is a raised to the power 4. So then this minus. Now, 16 can be written as 4 because 4 squared is 16. Then b squared, all of this squared. Now, this is a representation of this. But now we can apply difference of two square. Now, don't forget, when you have a square minus b squared, this can be written as a plus b into a minus b. So let's apply that here. So that is, we're going to be having 9a squared plus 4b squared into 9a squared minus 4b squared. Now, this part can also be written again such that we can have difference of two square. So we'll then have this as 9a squared plus 4b squared. Then this can then be written as 3a squared minus 2b squared. Now let's apply difference of two square here. So let me write that first. So that is, we'll have 3a plus 2b, then 3a minus 2b, then this now where we have 9a squared plus 4b squared. Now, looking at the options provided, 3a plus 2b, 2a minus 3b, that's out of it. 3a minus 2b, 3a plus 2b, 9a squared plus 4b squared. So the correct option is C. There. Let's solve this problem from Jamb 2021. Where we have to simplify and express in standard form this expression here. So we have 0.00275 multiplied by 0.00640, all divided by 0.025 times 0.08. Now, to solve this easily, just do to the numerator what you do to the denominator and ensure that what we have here can then be written as whole numbers. To write this as a whole number, I have to bring this decimal point 5 places back. That is 1, 2, 3, 4, 5. So that will become 275 times. Now let's do the same thing here. 1, 2, 3, 4, 5. So we would have 640 divided by, now this 1, 2, 3, 4, 5. That would mean we'll have 2 zeros there. So 2500 times. Same thing here. 1, 2, 3, 4, 5. That is 8,000. Filling up this space. Now 0 cancels 0. And then 8 here is 8. 8 here is 100. 25 goes here 11 times. 25 goes here 100 times. So what we have is 11 times 8 over 100 times 100. Now, this would give us 88 over 10,000, which can be written as 88 over 10 raised to the power of 4. Now, to write this in standard form, we can then say 88 times 10 raised to the power minus 4, giving it the negative index, and then this then becomes 8.8, moving the decimal point one step to the left, times 10. Then we add 1 to this. Minus 4 plus 1 will give us minus 3. So it's 8.8 times 10 raised to the power minus 3. So the correct option is C. Let's solve this problem that says solve for k in the equation 1 over 8 all bracket power of k plus 2 equals 1. In order to solve this, we have to ensure that everything has the same base. And this is how we can achieve that. Now, 1 over 8 can be written as 8 with a negative index of 1. Then this having k plus 2 equals 1. Now, the lowest possible base index for 8 is 2. And that is 2 with the power of 3. So if we're writing that, this will imply that we are going to be having 2. Now, the 3 times minus 1 will be minus 3. Power of k plus 2 equals. Now, to bring this to 2, 2 raised to the power 0 is the same thing as 1. So we just write it as 2 with the power of 0. So that way we have equal base index at both sides of the equality sign. Now let's open this. We then have 2 with the power of minus 3k. Then minus 3 times plus 2 will give us minus 6. All equals 2 with the power of 0. Now the base can then cancel. So we have minus 3k minus 6 equals 0. This can then be written as 3k equals minus 6. So to make k the subject, divide both sides by 3. And then we see that k equals minus 2. So the correct option is option A. Looking at this question, we are asked to evaluate 16 with the power of 0.16 times 16 with the power of 0.04 times 2 with the power of 0.2. To solve this, we ensure that they all have the same base index. So for 16, that will be 2 with the power of 4, all raised to the power of 0.16 for the first one here, times the second is also 2 to the power of 4, and this is 0.04 times 2 raised to the power of 0.2. Now let's expand this. This then becomes 2 with the power of, now what is 4 times 0.16? That would give us 4 times 6 is 24. 4 times 1 is 4 plus 2, that's 6. So 0.64 times 2. Now 4 times 0.04 would give us 0.16 times 2 raised to the power 0.2. Now let's add this up. That is, we're going to be having 2 power of 0.64 plus 0.16 plus 0.2. Let's add it together. 0.64 plus 0.16 plus 0.2. Now this gives us 0 carry 1. This is 10, so 0 carry 1. So we have power of 1. So here we have 2 with raised to the power of 1, which gives us 2. That is, the correct answer here is option A. This question on logarithm says, if log to base 8 of 10 is x, evaluate log to base 8 of 5. Now to solve a problem like this, here's what you do. Starting with the problem itself, so log to base 8 of 10 equals x. Now we have to find a way to write 10 in terms of 5. So that would mean that we would have log to base 8 of 2 times 5. And this equals x. And when you have products like this with a log, we can then separate this and then use addition. So that is, it can be written as log base 8 of 2 plus log base 8 of 5, and all of this equals x. Now, we are to evaluate log base 8 of 5, which is this part. So make that the subject. Log base 8 of 5 can then be written as x minus log base 8 of 2. Now, what we have to do is to find a representation for log base 8 of 2. Now, let's do that here. We can say log base 8 of 2, let's call that y. What this implies, according to indices, is that 8 with the power of y is actually 2. And we can write this as 2 cubed times y. Now that will be 2 raised to the power of 3y equals 2 with the power of 1. So since the bases are equal, we can then say that 3y equals 1. That is, y equals 1 over 3. That is, log to base 8 of 2 can be written as 1 over 3. So therefore, log base 8 of 5 would then be x minus this, which is 1 over 3. So x minus 1 over 3. The correct option is C. To solve a question in logarithm where each of the individual logs have different base like this, you have to first solve for each of them by working on the relationship between indices and logarithm. So, solution. First we say let log base of surd 2 of 4 equal x. Now what this means is that surd 2 power of x is 4. Now square both sides. Now surd 2 squared will give you 2. Then power of x. Now this equals 4 squared, that is 16. So bringing this to base of 2, you would have 2x equals 2 with the power of 4. And since the bases are equal, then the power should be equal. So x equals 4. That's for the first one here. Now to the second. Let log base of half of 16 equals y. Now what this means is that half with the power of y equals 16. Now we can write this to have negative index, so it will be 2 negative 1, so that is minus y, equals, now let's rewrite this, that will be 2 with the power of 4. And since the bases are equal, minus y equals 4. Therefore, y is minus 4. Now, to the third one, let log base of 4 of 32 equals z. What this means is that 4 with the power of z equals 32. Now, this can be written as 2 squared. So 2 power of 2, so 2 times z, we have 2z equals, then this is 2 with the power of 5. What this implies is that 2z equals 5. Therefore, z equals 5 over 2. Now, we can bring their individual solutions into this expression. So from the first one here, log of base 2 of 4, that we have solved to be 4. So that will be 4 plus log base of half of 16. We solved that and we got negative 4. Then minus log base 4 of 32. We solved that and we got 5 over 2. Now, what we have here is 4 minus 5 over 2. So 4 minus 4 is 0. And 0 minus 5 over 2 will give us minus 5 over 2, which is negative 2.5. That is, the correct answer is option B. To solve this problem, we're told that if log base of x power of half of 64 equals 3, find the value of x. We're going to work on the relationship between indices and logarithm. Now, this same question can be written as log. Now, x power of half is the same thing as saying square root of x. So, of 64 equals 3. And what this means is that the square root of x with the power of 3 equals 64. Now, in order to work with this, what we have to do is to break this down as well. So this is square root of x power of 3 equals, now what raised to the power of 3 would give us 64 is what we have to find now. So that is square root of x third is then, now you note that 4 times 4 is 16. And then 16 times 4 would give us 64. So that means we would have 4 cubed. So now that we've achieved them having the same power, it implies that the base are also going to be equal. So therefore, you can then say square root of x equals 4, since the power are equal. Now from here, to get rid of this square root, we're going to square both sides. Square both sides. And then square root of x squared, that is x squared, square root of x, then when we square that, would then be 4 squared. So this square gets rid of this square root to give us x, and then 4 squared would give us 16. That is, the answer is option B. This question gives us the value of log to base 10 of 2 and the value of log to base 10 of 7 as 0.3010 and 0.8451 respectively. And then we are asked to evaluate log to base 10 of 280. Now, take note, sometimes like this, questions like this may not carry the base. You know that when you write logarithm without indicating the base, it is taken to be base 10. So let's solve this. Starting with log to base 10 of 280. This can be written as log to base 10 of 28 times 10. And we can then write it as log to base 10 of. Now 28 is the same thing as 4 times 7. So 4 times 7 times 10. Now, as part of the laws of logarithm, whenever you have something like this, you can then rewrite it as the same log of this same base of 4 plus that of 7 plus that of 10. Now, what I'm saying is we would have log to base 10 of 4 plus log to base 10 of 7 plus log to base 10 of 10. Now, this can be written as 2 squared. So we would have log base 10 of 2 squared plus log base 10 of 7 plus log base 10 of 10. Now let's apply law of logarithm to simplify this further. This would imply that we would have 2 log base 10 of 2, since the power has to go to the left. So plus log base 10 of 7 plus, now log 10 base 10 is 1. Now, from the question, they've already stated what log base 10 of 2 is and what log base 10 of 7 is. So we just bring in their values into this expression. So we then have 2 into bracket log base 10 of 2, which is 0.3010, plus log base 10 of 7, that is 0.8451, then plus 1. Now let's multiply this. This will give us 0.6020 plus 0.8451 plus 1. Now let's add this. I can write this as 1.0000, and then we put the 0.8451 and then 0.6020. Now let's add 0 plus 1 plus 0, that is 1. 0 plus 5 plus 2, 7. 0 plus 4 plus 0, that is 4. 0 plus 8 plus 6, that is 14. So 4, carry the 1. Don't forget the decimal point. Now 1 plus 1 plus 0 plus 0 will give us 2. So our final answer is 2.4471. Now from the option provided, the correct option is B. Now in this question, you see that the base of the logarithms are not indicated. So this question here, you are going to take the base as 10. So we have simplified 2 log 2 over 5 minus log 72 over 125 plus log 9. Now applying the law of logarithm, 2 has to come here to become the power here. So we'll have log 2 over 5 squared. Now let's rearrange. So plus log 9 and then minus log 72 over 125. Now in this case, we're going to have log 2 squared is 4, 5 squared is 25, plus log 9 minus log 72 over 125. Now when you have something like this, recall that log m plus log n, when they have the same base, would give you log mn. So that is, you're going to multiply 4 over 25 by 9. So now we just keep log, and then we have 4 over 25 times 9. Now minus log 72 over 125. Now when we multiply this, we're going to have log of 36 over 25 minus log of 72 over 125. And again, when you have log of m minus log of n, As long as they have the same base, it can be written as log of m divided by n. So applying that, we then have log 36 over 25 divided by 72 over 125. Now we know that this can be written as log of 36 over 25 multiplied by, then we flip this and then we have 125 over 72. Now here 36 here 1, 36 here 2, 25 here 1, 25 here is 5. Now let's work with this. So that is what we have is log of 5 over 2. Now we can do something to this and make it log of 10 over 4. When we multiply numerator and denominator by 2, this way we keep it the same. So by doing so, the reason why we did this is because we want to ensure that we have base of 10. So one of them has to be 10 to make that work easily for us. So at this point, we can then have this as log 10 minus log 4, following this rule. So moving from here to here now. Now applying this, we know that log 10 base 10 is 1. So minus, this is the same thing as saying log 2 squared. So we can then finish it up by saying 1 minus, then 2 comes here, we would have 2 log 2. So 1 minus 2 log 2 is option D. So the correct answer is D. In this question, we have to find x if log base 9 of x equals 1.5. To solve this, we can write and say log base 9 of x equals, now 1.5 is same as 3 over 2. Now, we can then look at the relationship between indices and logarithm to solve. That is, the base here, which is 9, we then carry the power of 3 over 2, and this has to be x. Now, working with this, we can then say 3 squared power of 3 over 2 equals x. Now 2 cancels 2 here. Now we can then say x equals 3 cubed. So x is, now 3 cubed is 3 times 3, 9 times 3, and then we have 27. So the correct answer is in option A. Here's another question that says, find y if log of y plus 8 plus log of y minus 8 equals 2 log 3 plus 2 log 5. So to find y, we're going to solve it this way now. Now do not forget that if you have any question at all concerning what we have been solving so far or on any of the topics we've been working on, feel free to drop your question in the comment section. We're going to answer to those your questions appropriately. So to solve this, for the left-hand side of this equation, we can write it as log, taking just 1, and then applying the law of logarithm. That is, the product of this would then be y plus 8 into y minus 8. Now, this is difference of 2 square for those who have been following. Now, at this point here, we can then have it as log of 3 squared, taking 2 here, plus log of 5 squared. Now, as with every question where you have difference of 2 squared, this can then be written as log of, now, y squared minus, now 8 times 8 is 64. So, y squared minus 64 equals log 3 squared is 9 plus 5 squared, which is 25. Now here we then have log of y squared minus 64 to equate with, Now applying the same rule here, we then have the product of 9 and 25. So log of 9 times 25. Now let's find this here. So 25 times 9. 9 times 5 is 45, so 5 carry the 4. 9 times 2 is 18. 18 plus 4, and we have 22. So that's 225. So therefore, we can say log y squared minus 64 equals log 225. At this point, the logs can cancel out. So y squared minus 64 is then 225, which implies that y squared equals 225 plus 64. And when we add that, 5 plus 4 will give us 9. 2 plus 6, that's 8. And then 2. So y squared equals 289. And to get y, we'll find the square root of 289. And whenever you apply square root, your answer will be plus or minus. And square root of 289 is 17. So we have plus or minus 17. That is, the correct option is option C. Do not forget to like, share, and also drop your questions as comments. We'll attend to them appropriately. This question says, solve the logarithmic equation. And then we have this equation where we have log base 2 of 6 minus x in bracket equals 3 minus log base 2 of x. So we have to ensure that everything is in log of base 2. So to solve this, we'll go this route. Solution. In the first case, it's already in base 2, so we leave it at that. 6 minus x equals, now 3 times 1 is still 3, and 1 is the same thing as log 2 of base 2. That is log base 2 of 2. So that is, we can say 3 log base 2 of 2. Now this is the same thing as 1, and 1 times 3 remains 3. So no change has been done here, but we have managed to bring it to base 2. And then minus log base 2 of x. Now applying law of logarithm at this point, we would have log base 2 of 6 minus x equals log base 2 of 2 cubed minus log base 2 of x. Now from here, we can then have log base 2 of 6 minus x equals log base 2 of 8 minus log base 2 of x. So what we have to do now is collect like terms. So since we have x here, we have to bring this other part here now. So we would have log base 2 of 6 minus x. Now when minus log base 2 of x comes here, it becomes plus log base 2 of x equals log base 2 of 8. Now similar base, so what we do is we find the product of this. So we'll have log base 2 of x multiplied by 6 minus x equals log base 2 of 8. Now easily, log base 2 cancel log base 2. Now let's open this. X times 6 will give us 6x minus x squared equals 8. Now let's rearrange this so that we have a quadratic equation. When this comes to the other side, we would have x squared. It will be positive now. When this comes there, it becomes minus 6x. This is already there, so plus 8 equals 0. Now we can then apply any method to solve this quadratic. Now looking at this, the product here is 8x squared, and what we have here as b is minus 6. So two numbers that will give us 8 when we multiply, but 6 when we add is 4 and 2. Now minus 4 times minus 2 will give us minus 8, will give us plus 8, which is what we have here. And then minus 4 minus 2 will give us minus 6, which is what we have here. So that tells us that this is our factor. So we can then go on to say x squared, then minus 4x minus 2x plus 8 equals 0. Now let's group them. What this means is that when we call out what we have in common here, x, we'll be left with x minus 4. And here, if we call out minus 2, we'll be left with x minus 4. All equals 0. Now, all of this implies that x minus 4 equals 0 or x minus 2 equals 0. Now, from here, we can say x equals plus 4 or x equals plus 2. So, x equals plus 4 or plus 2 being our answer, that is the correct option is A. Here's the question that involves surds. We're told to find the value of x if surd 2 over x plus surd 2 equals 1 over x minus surd 2. Now, if you want to brush up your surds, you can check out our videos on surds right here in this channel. Now, let's solve this problem. To solve this problem, first thing we want to do is to cross multiply. So we would have surd 2, open bracket, x minus surd 2 equals 1 into x plus surd 2. Close the bracket. Now, surd 2 times x will give us x surd 2 minus surd 2 times surd 2 will give us 2. And this equals x plus surd 2. Now, what we have to do here is to collect like terms. When we do so, we're going to be having x surd 2 minus x equals 2 plus surd 2. Now, here we see that they have x in common. So if we call out x, we'll be left with surd 2 minus 1. And here we have 2 plus surd 2. Now, dividing both sides by surd 2 minus 1, we're going to find that x equals 2 plus surd 2 over surd 2 minus 1. Now, remember you cannot leave your answer in surds at this form. So we have to multiply numerator and denominator by conjugate surd of the denominator. So x therefore becomes 2 plus surd 2 multiplied by surd 2 plus 1, which is the conjugate of the denominator here. And we do the same thing to the denominator. Surd 2 minus 1 multiplied by surd 2 plus 1. X therefore becomes, now 2 times surd 2 will give us 2 surd 2. 2 times 1 will give us plus 2. Surd 2 times surd 2 will give us plus 2. And surd 2 times 1 will give us plus surd 2. All over surd 2 times surd 2, that is 2. Surd 2 times plus 1, that's plus surd 2. Minus 1 times surd 2 will give us minus surd 2. And then minus 1 times 1 would give us minus 1. Here we see that plus surd 2 minus surd 2 gives us 0. So x equals, now 2 surd 2 plus surd 2 will give us 3 surd 2. Plus 2 plus 2, that is 4. All over 2 minus 1, and we have 1. So therefore x is 3 surd 2 plus 4. Or we just say x equals 4 plus 3 surd 2. Whichever way we arrange, we are right. So let's look at the option now. We have 3 surd 2 plus 4. So option A is the correct answer. This question says if 1 plus surd 2 all divided by 1 minus surd 2 is expressed in the form of x plus y surd 2. Find x and y. So basically what we have to do is to rationalize this surd. And to do that, we're going to multiply the numerator and denominator by the conjugate surd of the denominator. So that is, we'll have 1 plus surd 2 multiplied by 1 plus surd 2. Now, this is the conjugate surd of this denominator. So we do the same thing to the denominator. 1 minus surd 2 into 1 plus surd 2. Now, let's expand. 1 times 1, 1. 1 times surd 2, that's plus surd 2. Plus surd 2. And then surd 2 times surd 2 will give us 2. All over. Now, 1 times 1 is 1. 1 times plus surd 2 will give us plus surd 2. Minus surd 2 times 1 will give us minus surd 2. And minus surd 2 times plus surd 2 will give us minus 2. Now, 1 plus 2 here gives us 3. Surd 2 plus surd 2 will give us plus 2 surd 2. All over. Now, surd 2 minus surd 2 is 0. So, 1 minus 2, that's minus 1. Which is the same thing as just writing negative sign into 3 plus 2 surd 2. Now, minus, let's open this bracket with the minus sign. We'll then have minus 3 minus 2 surd 2. That is, x is minus 3 and y is minus 2. So, our answer is minus 3, minus 2. The correct option will be option A. In this question, we have to simplify 5 surd 18 minus 3 surd 72 plus 4 surd 50. Now, to do this, we have to find the highest perfect square we can get from this number when we express that as the product of two numbers. So we can then say, in this case, 5 into surd 18 can be expressed as 9 times 2. Now, you see that 9 is a perfect square, while 2 isn't. So that tells us that our answer will be in surd 2, right? Now, for those who are very fast, from here alone, they can go ahead and just know that the answer is C. But let's complete it so that you can see. So from here, we then go to minus 3. Now, this can be expressed as 36 times 2. This is a perfect square also, so that is, we'll be left with something in surd 2 here. Then plus 4 surd. This is then 25 times 2. So you see, all of them will end in surd 2. So we can see that C is the answer already, but let's finish up. So from here, we can then have 5 times surd 9 times surd 2. Now, let's do this addition next. Plus 4 times surd 25 times surd 2. Then minus now 3 times surd 36 times surd 2. Now, this will give us 5 times 3 surd 2 plus 4 times 5 surd 2 minus 3 times 6 surd 2. 5 times 3, that's 15 surd 2 plus 4 times 5, that's 20 surd 2 minus 3 times 6 is 18 surd 2. Now, when we add these two, we would have 35 surd 2 minus 18 surd 2. So the final answer is 17 surd 2. So the correct option is C. Now, this question says, simplify surd 27 plus 3 over surd 3. Now, in order to solve this, we have to first rationalize this, right? So, take note of this. This same question can be written now as surd 27 plus, now multiply this by surd 3, and then you have 3 surd 3 over, now surd 3 times surd 3 will give you 3. So this is how we rationalize simple surds like this, that we can then go on to finish up this. Now this can be written as sort of now 9 times 3. So plus 3 sort 3 over 3. Now when we work with this, we can then break it down to sort 9 times sort 3. And sort 9 is 3. So 3 sort 3 plus 3 sort 3 over 3. So this can be written as over 1. When you take LCM, that will be 3. 1 and 3, that's 3. 3 times 3, that is 9 sort 3. Plus 3 here 1. 1 times this remains 3 sort 3. Now we can simplify this by looking at what they have in common. So they have 3 in common. That will leave us with 3 sort 3 here plus sort 3 all over 3. So 3 can then cancel 3. That's why we factored it out, so that it can cancel out like this. So our final answer would then be 3 sort 3 plus sort 3, which is 4 sort 3. So the correct option is A. Now in questions like this, we are asked to simplify 1 over 3 minus sort 2 in the form of P plus Q sort 2, right? Now when you consider the options we are provided with, now most people are quick to say that the answer is definitely going to be D, because all these other ones are not put in the proper form. Like in this case, you still have to rationalize this part. The same thing here, we are having denominators in sort form, which is not proper. So many are quick to say this is the answer. It might be the answer, but you always have to check before you choose your answer. So let's solve this case. So to solve this, we have to rationalize this sort first. So we multiply the numerator and denominator by the conjugate sort of the denominator. So that is, we'll have 1 multiplied by 3 plus sort 2. That's the conjugate sort of the denominator. Now, for the denominator, we'll have 3 minus sort 2. Now, multiplied by 3 plus sort 2. Now, let's see what this gives us. So now we have 3 plus sort 2 over. Now, 3 times 3, that's 9. 3 times sort 2, that's plus 3 sort 2. Minus sort 2 times 3 will give us minus 3 sort 2. And then minus sort 2 times plus sort 2 will give us minus 2. Now let's tidy that up. So now we have 3 plus sort 2 over. Now this and this gives us 0. Now we have 9 minus 2. And this gives us 7. So we see that the answer is D. But let's finish it up. So here we'll then have 3 over 7 plus sort 2 over 7. And that's the solution to this problem. Now please ensure that you like, share, and drop a comment on any question at all you would like us to shed more light on. I hope to see your comments in the comment section. See you in the next video.